Salam everybody, welcome to Physics with Norshir and we're discussing this paper. Now before I start this question, just to remind you, the formula is Q is equals to MC delta T where Q is energy. Energy is power in time. And how do you calculate power? VI. Whenever you have an electrical heater, you have to give it voltage, you have to give it current, T is the time, M is mass, C is specific heat capacity, and delta T is the temperature difference, which is noted by the thermometer. Now, this is a question of an experiment in which you want to find the value of C. Now, how do you find the value of C? You basically find out all other values. And that is exactly what they're saying in the first question, that you need to show us a list of the measurements. You don't have to write this formula. Just show us a list of all of the measurements that you will take to calculate the value of C. So V is potential difference, I is current, T is the time for which you heat it, M is the mass of the block, the aluminum block that you're using, delta T is the temperature difference, and I've explained what temperature difference is. It's the final temperature minus the initial temperature. You just make this list and you'll get the 4 marks. Next, they're asking you for the formula that you use to find the specific heat capacity. The same formula that I wrote above, VIT over M delta T. You just have to make C the subject. And delta T needs to be explained that it's the final temperature minus the initial temperature. And now another student performs this experiment without the insulation, obtains a higher value for C. Because what he's doing is, without the insulation, what's happening from the block, heat will be lost to the surroundings. Now, if heat is lost to the surroundings, tell me something. I have this thermometer inside. The thermometer is noting the temperature rise. If heat is being lost to the surroundings, there's a heat loss happening from all sides. Tell me something, that will this temperature rise be higher or lower? The temperature rise or the change in temperature will be lower. And if you look at the formula, C is equals to VIT over M delta T, where delta T and C have an inverse relationship, you can clearly see. अगर आपका change in temperature ही कम हो गया है, तो what will happen to the value of C? The value of C will be higher. So that is what we're saying, that due to the heat loss to the surroundings, the temperature rise is less. And because the temperature rise is less, therefore your heat capacity will be more. So if you use an insulation, the temperature rise will be more and the heat capacity that you will measure will actually be reduced. Question number 2, part A, they ask you to draw a normal on any one of the rays. Read the question carefully. On any one of the rays, so either on this one or on this one, just draw a straight line, and this is your angle of incidence. You have to mark your angle of incidence as X. Next part says you have to draw the reflected rays and construction lines to locate the image of the object. Now, be careful in this question. Let me zoom in. The first step that you need to do is, before you draw these lines, before you draw the reflected rays, although that's part A, and part B is to locate the image, please make sure that if this is your object, just count the number of boxes, 1, 2, 3, 4, 5. Then this is another 5 boxes, another 5 boxes, 15 boxes. So your image should also be 15 boxes above the mirror. So 5, 10, 15 boxes. 15 boxes above from the mirror. This should be your image. Once you have your image, you should work your way smartly. You know that this is the point of incidence. This is the point of incidence. So आप यहाँ से straight line खींचो all the way to this point and take it forward. यहाँ से straight line खींचो all the way to this point and take it forward. And then the lines which are behind the mirror, make them dotted. And the lines which are in front of the mirror, make them thick. Make sure that you've given the direction of the rays as well. अगर आप ये नहीं करते, let's say for example, आप कहते नहीं, मैंने यूँ करना है, that first I'm going to give my incident ray the reflected ray. This is the reflected ray. Similarly over here, this is the normal. So this is angle of incidence. This is my reflected ray. Andazan, for example, because you're not using protractors or compasses to measure anything. And now when you extend them backwards, पता चलेगा वो मिल ही नहीं रही. And if they don't meet, then you can't find the image. So what is the way? The way to do this question is to ignore and avoid all of this mistake. First, locate the image. So if this is the object, the image should be here. This is the image. And then you work your way the other way around, which means that rather than making these lines before, you rub these lines and you say, no, this is not needed. This is also not needed. आप क्या करोगे? आप ruler लोगे. You'll take a ruler and you will draw a straight line. Let me show it to you. You will draw a straight line from the image to that green line or to that green point. Let me show it to you. I'll do it like this. Okay, just draw a straight line and take it forward. Done. Arrow ka direction de do. And now what you do is rub off the part behind the mirror because that's not real. So you have to make it dotted. These जब आप dotted कर देते हो इसको हम बोलते हैं construction line. Do you understand? Now similarly उसी image से एक और straight line बनानी है all the way to the other point of incidence. So the other point of incidence, let me show it to you. That line will look like this. Oops. That line will look like this. Once you've drawn this, give it the direction, and behind the mirror, please make sure that your line is dotted. So this is dotted, 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 and that's it. This is your ray which is constructed. And now on the second ray, just draw the normal as well. And this is the normal. That's it. Done. Now in part B, please remember that the barrier is like a mirror. So if this is the source and they ask you to find out where is the reflected wavefront coming from, then remember the source is like your object and the barrier is like a mirror. So you have to go the same distance behind the mirror and find the image. This is where the reflected wavefronts appear to be coming from. And then they ask you to draw as accurately as possible the reflected circular wavefronts. Remember, in reflection, the wavelength does not change, and the gap between the two wavefronts should be the same even when you're reflecting them. So if this is the gap, this is the gap. When I make the reflections, the gap should remain the same. और याद रखो कि you're always going to show your reflections from those single points which hit the barrier, not these points. The single point that hit the barrier. So this is a single point, this is a single point, this hits the barrier. So you will have, so your reflected ray should look like this. And then this is your next single point, this is your next single point, this is what your reflected ray should look like. And if you notice that if I extend them backwards, ये circle बन रहे हैं. अगर आप देखोगे तो ये आपको लगेगा, it will feel as if this is the center of these circles and the gap should remain constant. And you're only making these two because you're only making these two wavefronts because you only got these two fixed points or single points over here and these two single points. If they had given you a third, for example, they'd given you this and this, then you would have definitely joined this point with this point as well, like this. Keeping sure, try your best that the gap remains the same. So the gap should be as big as these incident waves. Let me show you the actual diagram. This is what the actual diagram looks like. Whatever gap you have over here should be the same gap over here, and try your best that the gap remains constant everywhere else as well. That's why they said draw as accurately as you can. Now, when you're making helium molecules, please make sure that they are widely spaced out. Don't make them close. So the attractive forces between gas molecules are very weak. They're much smaller in magnitude. You have to mention this because they're asking you how the size of the force varies. So you have to tell that the size means magnitude. The magnitude is much smaller as compared to the forces between molecules and solids. Now part B is a really good part. Listen to me very, very carefully. The pressure of helium in each balloon is 1.1 times per 5. So one balloon can only take a pressure of 1.1 into 10 to the power 5 pascals. You have a cylinder. The cylinder has this volume and the pressure is 2.75 into 10 to the power 6. So this is the volume and this is the pressure in the cylinder. This is the initial volume and the initial pressure. This cylinder is supposed to fill up this balloon. Now just imagine if I put this balloon on top of this cylinder and I let the air flow, this pressure will be applied to the balloon will explode. So first step is to bring the pressure in the cylinder down to this level of 1.1 in 10 to the power 5. The pressure in the cylinder has to be reduced. So I need to bring the pressure in the cylinder to this level. Why? Because this cylinder has to fill up the gas in the balloons. If the balloon cannot take more than 1.1 tons per 5, the pressure in the cylinder cannot be more than 1.1 tons per 5, otherwise the balloon will explode. Abhi pressure 2.75 hai, phट जाएगा. We don't want it to explode. Therefore, पहले तो cylinder के अंदर pressure को 1.1 tons per 5 बनाए. For that, you will have to change the volume of the gas in the cylinder. And what will that volume of the gas be? You'll do P1, V1 is equals to P2, V2. P1 is 2.75 tens per 6. V1 is 6 in 10 to minus 3. P2 is 1.1 tens per 5. V2 is 0.15. So the volume of the cylinder now is 0.15 meter cube. So you guys tell me, I have this tank, and this tank had an initial volume of 6 into 10 to the minus 3 meter cube. I started filling balloons, filled up one balloon, then filled up the second balloon, then filled up the third balloon, then the fourth balloon, then the fifth balloon. And the volume in the cylinder changed from 6 into 10 to the minus 3 to 0.15 meter cube. Can you tell me what was the volume that was given to all of these balloons? The volume of the gas inside the cylinder was 6 into 10 to the minus 3. Then it became 0.15 as I filled up the balloons. What is the volume that was given to the balloons? So the total volume of gas given to the balloons would be the difference between these two numbers, right? Because this was the initial volume, this was the final volume in the cylinder. So what is the volume that was given to the balloons? It must be the difference in these two volumes, right? So the difference in these two volumes will be 0.15 minus 6 into 10 to the minus 3, that is 0.144 meter cube. Now, each balloon needs a volume of 0.003. Each balloon. One balloon requires 0.003. I am giving 0.144. How many balloons can I fill up? Just divide. You'll get 48 as the number of balloons. Now the temperature increases and the balloon bursts. Why? Because pressure is proportional to temperature. When you will increase the temperature, the pressure will increase. The pressure will increase. What will happen? The molecules will collide more vigorously or with greater speed with the walls of the balloon, and as a result, more force will be exerted on the walls of the balloon, and hence the balloon will burst. The two conditions for equilibrium are, number one, sum of forces on the object must be zero. You can also say no resultant force. The second is sum of moments acting on the body must be zero. You could also say no resultant moment. You could even say clockwise moments is equals to anti-clockwise moments. And I've made this object that, first of all, if this is the object which is in equilibrium, and you have forces F1 and F2 which are pulling this object down, then there must be a force which is upward, which is, let's say, R, and R must be equal to F1 plus F2. Only in that case will the object be in equilibrium. And secondly, if it is in equilibrium, then the moment of this side must be equal to the moment of this side. So the clockwise moment must be equal to the anti-clockwise moment. Now you have this guy who's holding this wheelbarrow. The weight of the wheelbarrow is pointing downwards. There's the force Q acting upwards, and there's the force P acting upwards. And this point is going to be your pivot. The first question is, would force B be large or small as compared to W? Please try to understand. P is pointing upwards, Q is pointing upwards, W is pointing downwards. So can I say, if it is in equilibrium, that P plus Q would be equal to W? Can we say that? Upward forces must be equal to downward forces, first condition of equilibrium. So मुझे बताओ, ये जो P है, this is going to be W minus Q. Is P bigger than W or is P smaller than W? P is smaller than W. Because W में से Q को subtract करते हैं, W में से you remove something, then you get P. So that means W is bigger, P is smaller. And secondly, if you think of it in terms of moments, please try to understand that this point is your pivot. And remember this fact, that when a force acts on a pivot, it has no moment. Because moment is force and distance. Even if you have a lot of force, which is Q, but it's acting at the pivot, the perpendicular distance will be zero. The moment due to Q will be zero. So if this is your pivot, the first thing that you should write is that the moment due to Q is zero. So that means you're only left with two other forces. One is P and the other is W. Now, if this is the pivot, where is W going to take you? W is going to take you in this direction, because this is the pivot and this is the force which is acting this way. And if you don't understand this, always make a clock. 12, 3, 6, 9. This is your pivot. The same pivot over here is this pivot. You have a force on the left side of the pivot, so just make a force on the left side of the clock. Let's say this is the force, and let's call this force the same name as given in the question. This is W. Now you tell me, if this is the object, it's pivoted at this point, and you apply a force W on this, will this clock turn? Yes, of course it will turn. It will turn in this direction. So is this clockwise or anti-clockwise? You're going from 9 to 6. This is anti-clockwise. Do you understand? And similarly, this is your pivot. You have a force P which is acting upward, and it's also on the left. So on the clock, just make a force upwards. This is P, which is acting on the left side. So left side. And imagine this is the pivot, और आप इस घड़ी पे इधर force लगाते हो. Where will this clock turn? This clock is going to turn in this direction. So it's going to go from 9 to 12. So this is going to be clockwise. And if the object is in equilibrium, then your clockwise moments must be equal to your anti-clockwise moments. So clockwise moments must be equal to your anti-clockwise moments. So F1 D1 must be equal to F2 into D2. So P into this distance should be equal to W into this distance. This clock I only made to make you understand clockwise and anti-clockwise. You cannot get any idea of the distances because obviously this is a wheelbarrow and this is a clock. So this clock is only used for your understanding of clockwise and anti-clockwise. This clock cannot be used to tell the distance because for distance you'll have to refer to the actual diagram. Now in the actual diagram, if this is P, what is your distance from the pivot? याद रखो pivot से distance निकालने के एक ही simple सा तरीका है वो ये है. Is P vertical or horizontal? It's vertical. So just make a vertical line on the pivot. So if this is the vertical line that is on the pivot, what is the distance between these two lines? I'm giving it the distance D1. So this is the distance that I'm going to use for my moment. So P into D1. Similarly, W is also vertical. Make a vertical line on C. What is the distance of W from the pivot? I'm giving it the name D2. So W into D2. So P into D1 should be equal to W into D2. Now you must remember that since D2 is less, hence you will have a large W. जितना distance कम होता है pivot से, force उतनी ज़्यादा होती है. जितना distance ज़्यादा होता है pivot से, force उतनी कम हो जाती है. So P is going to be less than W, even if you try to prove it through clockwise moment is equals to anti-clockwise moments, which is the second condition of equilibrium. And that is what the first part says. So by considering forces P, Q, and W, tell us what do you think. We're saying P is less than W because P is W minus Q. And by considering moments, we know clockwise equals to anti-clockwise. So P into D1 should be equal to W into D2. So if you make P the subject, it'll be W into D2 over D1. And then you will say, since D1 is more, since D1 is clearly the bigger distance, P will be less. W is constant, D2 is constant, they're not changing. So you can clearly see that since D1 is larger than D2, then P will be less. They have an inverse relationship. Very similar concept in part C. If this is your pivot, your support is always your pivot, remember this. And this is the weight. And I ask you, will this weight make you turn clockwise or anti-clockwise? Just make the clock again. Mark your pivot in the center. And this force G is on the right of the pivot. So just make a right arrow down. And now tell me, if this is the pivot and you're applying a force this way, where will this clock turn? This clock will turn like this. So this is going to be clockwise, correct? And now you have this screw, which is applying a force this way. This is your pivot. Just make the same force in this direction. And now tell me, will this force make you turn clockwise or anti-clockwise? It'll go from 12 to 9, so it'll be anti-clockwise. And because it is in equilibrium, hence your clockwise moment must be equal to your anti-clockwise moment. This is anti-clockwise, and the lower weight is going to make you turn clockwise. But like I said, you can't have any idea of what the distances are. This is only for your clockwise and anti-clockwise sense. So let's go back to this diagram. Now to calculate the clockwise moment, what distance should I take? Should I multiply 75 with 0.75 or 0.24? Whenever you're confused, मैंने अभी थोड़ी देर पहले समझाया, whatever the direction of force is, go to the pivot and make a line in the same direction as the force, and then just measure the distance between the two lines. So this is the distance that will be multiplied with 75, And if this is the force F and you don't know whether to multiply it with 0.75 or 0.24, very simple. Force F is horizontal. Go to the pivot, make a horizontal line, and just look at the distance between these two lines. It's 0.75. So F into 0.75 should be equal to 75 into 0.24. And when you do that, your answer will be 24 newtons. Now you have a sound wave. A sound wave is longitudinal, and because you can hear it, the frequency has to be in this range. So part B says, what is the process that occurs when the wavefront strikes the boundary? That is reflection. And let me show you what it looks like. So the first thing that's going to happen is that the wave is going to hit the mirror or the boundary, and you will make it in a straight line like this. And then when it hits, you will have a normal over here. Let me show you the normal. This is going to be the normal. And then you know that the reflection angle is the same as the incidence angle. So just try to make it as close as possible, but it doesn't have to be super accurate. Oops. My God. 1 second. Yeah. So it doesn't have to be super accurate, but you do get an idea that this is what it will look like. Now, a question was asked by a student, and that was, how will we draw the wavefronts if they ever ask us to draw the wavefronts? So firstly, they will give you more wavefronts than just one wavefront. Let me draw more wavefronts for you. When I'll draw more wavefronts, let's say, gee, this is one wavefront, then this is the next one, and they will extend the wavefronts to the boundary. Remember, they will give wavefronts which are extended to the boundary. Now, let's say these are the wavefronts that are approaching. I'll extend the third one as well. Just give me a sec. Do it with me so that you have an idea. So let's say these are the three wavefronts that are hitting the boundary. So always remember, reflection is only at those single points which hit the boundary. Just like what I explained to you earlier. And if I ask you this question, can you guys tell what is the angle between the wavefront and the direction of travel? Is it in 90 degrees? So always remember that the angle between the direction of travel and the wavefront is 90. So if this is your direction of travel, then the wavefront must be at 90 degrees to the direction of travel. So this is the direction of travel. So the wavefront must be at 90 degrees. So just to give you an idea, the wavefront cannot be like this. This is not 90. The wavefront cannot be like this. This is not 90. The wavefront will be somewhat like this. Do you understand? The wavefront will be somewhat like this. So what you have to do is, you have to go to these points. These two are just for the idea. You have to go to these points, the points which are hitting the boundary, hitting the mirror, and you have to make wavefronts somewhat like what I showed you. So it will be like this, this, and this. And all of these wavefronts will be traveling in this direction. So these are your reflected wavefronts. They're traveling in this direction. So you can even extend them. You can even continue making this pattern forward. But your requirement is that you have to show us at those points where they hit the boundary. So this is going to be it. Then this is going to be it. Then this is going to be it. Do you understand? All of these white lines that I'm making now are your reflected wavefronts. And the reflected wavefronts are traveling in this direction, the direction of the travel of the reflected ray. In terms of wave theory, how do we explain reflection? That a new wavefront is generated, and the new wavefront has the same speed, same frequency, same wavelength. That is why we made them equidistant, because the speed remains the same, frequency remains the same, wavelength remains the same. And then the question could come in your mind, how do we explain in terms of wave theory what will happen in refraction? So in refraction, again, you will say a new wavefront is generated. So this line will be copy pasted. But when you'll copy paste the second line, you will say the frequency will be constant. However, your speed and wavelength will be different. Speed and wavelength will be different because in refraction, you're moving from one medium to another. So although a new wavefront will be generated, you will say that your frequency will remain constant, your speed and wavelength will be different. So in reflection, there is no change in the wavelength, as you all know. Then you have to apply the formula V is equals to F lambda, get the frequency 43 hertz. Question number 6 again has to do with moments. Clockwise should be equal to anti-clockwise, and this point is now going to be your pivot. So now you can do it yourself. This is your pivot, this is the force acting downwards, so it'll give you a clockwise moment, whereas this 40 Newton force is going to rotate you in this direction. So it's going to give you an anti-clockwise moment. First question is, what is the weight? Weight is equals to mg, and you get the weight as 18 Newton. Now, what is the pressure? Pressure is force over area. Now, if you have a look at the question, they're giving you the dimensions, height, width, and they're now telling you the thickness. So they've shown you the height, they've shown you the width, but they haven't shown you the thickness. The thickness is actually going to be like this. So this is going to be your thickness, T. And when you multiply 0.3 with your thickness, what will happen? You will get the base area of this container. And if you divide the weight by base area, you will get the pressure. So pressure is force over area. Force is 180. Area is 0.3 into 0.04. Pressure will be 15,000 pascals. So the moment of the 40 Newton force, as you know, 40 Newton force is acting this way, and the perpendicular distance of the pivot is 0.6. So the moment is going to be 40 into 0.6, 24. Moment of W. W is acting vertically downwards. They ask you to make W. So you've made W vertically downwards. And what is the distance from the pivot? The distance from the pivot is going to be this distance, because I've told you the technique. If the force is vertical, just make a vertical line on the pivot and just look at the distance between the two vertical lines. It's going to be 0.15. So 0.15 into W gives you 27 Newton meters. And then part 3 is that the ground is rough, so the slab does not slide. What will happen if you increase this force gradually? So if you make it 50 Newton, 60 Newton, 70 Newton, what's going to happen? This moment is going to increase. And if this moment increases, then it'll eventually become greater than the clockwise moment, and the block might topple.